All right, let's talk about that moment. That feeling every developer gets when their good old, reliable SQL database just starts to choke. If you've ever been there, you know what I mean. Today, we're diving into the world of NoSQL, a whole different set of tools built to handle the wild demands of modern apps. So, to really get why NoSQL is such a big deal, we got to look at the problem it's trying to solve. For, decades, relational databases like Postgres have been king. They're organized, they're super reliable, perfect for structured data. But what happens when you grow? What happens when you hit that wall, when the very structure that made them so great suddenly becomes a bottleneck?
Have you ever had this happen? You build an app, it's taking off, getting popular, and then it just slows to a crawl. Pages take forever to load, you start getting complaints, and you look at your server, and the database CPU is just pegged at 100%. If that sounds familiar, congratulations, you've officially hit the relational database wall.
Let's make this real. Imagine you're building a social media app. You've got a single post, but that post has an author, it has images, it could have thousands of likes, and a whole tree of nested comments. In the SQL world, that's a nightmare. To get all that data, you're looking at joining, 5 different tables? At least. The result? A 200 millisecond response time just to load one post. And in today's world, that's an eternity. And if you think that's bad, it gets way more expensive in e-commerce. Picture it. It's Black Friday. Your site is getting absolutely hammered. If your database can't keep up with tens of thousands of people all trying to look at the same hot products, your pages grind to a halt. People get frustrated, they abandon their carts, and you're just bleeding money. In this case, maybe $100,000 an hour. That's not just a performance issue. That is a catastrophic failure. And this is where NoSQL comes into the picture. The name itself, not only SQL, tells you a lot. It's not about throwing away your relational databases. It's about having alternatives for these specific, tough problems. NoSQL databases are built from the ground up for 3 things: flexibility, incredible speed, and scaling to handle millions, even billions of users. But here's the thing you gotta understand. NoSQL isn't one single database. It's a whole category of them, and each one has its own special talent. To make sense of it all, we're gonna use a pretty simple analogy that I think really helps. Just think about organizing stuff in your house. So think of your classic PostgreSQL database as a perfectly organized file cabinet. Every folder's labeled, every paper has to be the right size, and everything has its strict place. It's great for order. But then you've got something like MongoDB, a document database. That's more like a bookshelf. Every book on the shelf is its own self-contained story. The books can be different sizes, different formats. You can easily add a new one. This is perfect for stuff like product catalogs or blog posts, where every single item might have slightly different details. Now, getting a file from that cabinet takes a second, right? You have to find the right drawer, the right folder. Compare that to something you know by heart, like your own phone number. It's just there. Instant recall. That's Redis. It's an in-memory database, which means it keeps data right in RAM. It's unbelievably fast, which makes it perfect for caching those popular products from our Black Friday disaster, or for keeping track of user sessions. And finally, there's DynamoDB. I like to think of this one as a massive, pay-as-you-go storage unit. You have a practically infinite supply of boxes, you find whatever you need by its box number, and you only pay for the boxes you're actually using. This kind of model is an absolute game changer for serverless apps that have to deal with huge, unpredictable spikes in traffic without you having to manage a single server. Okay, so we've got these different tools. We've got our file cabinet, our bookshelf, our brain, our storage unit. How do they actually work together in a real application? Let's take a look at the architecture of a modern e-commerce site to see how this all plays out. This is what people call a polyglot persistence approach. It's a fancy term for a simple idea. You don't pick just one database for everything. You pick the right tool for each specific job. So your product catalog with all its varied attributes, that goes into flexible MongoDB. Those top 100 products everyone's looking at, they get cached in lightning-fast Redis. All the users' shopping carts and sessions, that's a perfect job for the massive scale of DynamoDB. And what about your critical order history, the financial stuff? That stays right where it belongs, in a super reliable Postgres database. Now, using these new, powerful tools isn't always a walk in the park. It's not just about learning new code. It's about learning a new way of thinking. So let's go for a few of the biggest mistakes developers make when they first jump into NoSQL, and of course, how you can avoid them. Okay, this first one is probably the most common mistake of all. trying to treat MongoDB like it's just another SQL database. The classic error is to separate everything into different collections, one for users, one for posts, one for comments, and then make 3 separate trips to the database to piece it all back together. This totally, completely defeats the entire performance benefit of using a document database in the first place. The right way to do it is to really embrace the document model. You embed the data that belongs together. So the author's info and all the comments, they live right inside the post document itself. What does that mean? It means with one single, super fast query, you get everything you need. No more joins, no more extra trips to the database. It's a huge shift in how you model your data, but it's so worth it. All right, mistake number 2 can literally crash your server. Remember how Redis is an in-memory database? Well, that memory is finite. If you're storing things in Redis like user sessions and you forget to tell it when to get rid of them, that data lives there forever. So your memory usage just keeps climbing and climbing and climbing until, boom, your server runs out of memory and everything goes down. Luckily, the fix is incredibly simple, but it is so important. Always set a time to live, or TTL. You just use a command like setX that tells Redis, hey, automatically delete this key after a certain number of seconds. For a user session, maybe that's 24 hours. For some hot product data that changes a lot, maybe it's just 5 minutes. This is how you keep your cache clean and effective. Our final pitfall is a really expensive one, especially if you're using DynamoDB. A common mistake is to use the scan command to find something by an attribute that isn't its main key, like trying to find a user by their email address. A scan does exactly what it sounds like. It reads every single item in your entire table. If you have millions of users, this is not only painfully slow, it's also ridiculously expensive, because you pay for every single item it has to read. The real solution here is to design your database for how you're going to access it. You create something called a global secondary index, or GSI, on the email attribute. Now, instead of scanning, you can use the super efficient query command to find that user instantly. The difference is just mind-blowing. We're talking about an operation that can be 500 times cheaper and 3,000 times faster. It's a no-brainer. So we've covered the problems, we've looked at the different tools, and we've walked through the biggest pitfalls. How do you take all of this and actually make the right choice for your own project? Well, this flowchart is a great place to start. Think of it as a little cheat sheet. First, you ask yourself, do I need complex joins and super strict reliability, like for financial transactions? If the answer is yes, just stick with good old Postgres. If not, we move on. Is my data structure kind of fluid, always changing? MongoDB is your friend. Do I need insane microsecond speed for caching? That's a job for Redis. And finally, am I building a serverless app that needs to handle crazy, unpredictable traffic? DynamoDB was built for that. And that just about wraps it up. The world of databases can seem really complex, but I hope understanding these core ideas helps you feel more empowered to build faster, more scalable, and just plain better applications. So the question I want to leave you with is this. As you think about the project you're working on right now, or the one you're about to start, what's the right tool for your job?